In this video, I'll show how to create a simple dress, animate it with a looping walk cycle, and import it into Canvastique 3D. First, we'll use MakeHuman, an open-source tool for creating human models. MakeHuman makes it easy to create an avatar by simply adjusting sliders and selecting a few options. For our purposes, we don't need detailed skin textures or specific topology. I will only use the main tab sliders to shape your avatar. When ready, find the Export window under the Files tab. Be sure to set the units to meters to ensure proper scaling. Finally, export your avatar as an FBX file. Now, let's import our model into Blender and start setting up our cloth simulation. Add a plane mesh, rotate it 90 degrees along the X-axis and position it so it is centered in relation to our avatar. In Edit mode, apply a loop cut in the middle. Select the left side vertices and delete them. You can now apply a mirror modifier along the X-axis to save time by only having to work on the right side of the mesh. In front view, move the vertices to outline the shape of a long dress. Add loop cuts vertically and horizontally to increase the number of vertices as necessary. This will give you more control over the shape. In Object mode, apply the mirror modifier that was previously assigned to the pattern. Select the avatar and add a collision modifier, leaving the default values. Select the pattern and add a cloth modifier, also with default values. With both objects selected, rotate them 90 degrees along the X-axis relative to the world origin. Expand the timeline window and hit play. Press the same button again to pause the simulation when the pattern surrounds the avatar. This should give an overall idea of how well the pattern will wrap the avatar once sewn. If necessary, apply changes to the pattern in Edit mode and start the simulation again. Repeat until satisfied, but remember that we can still fix things later. Apply the cloth modifier to the dress. In Edit mode, start adding sewing lines to the back of the dress by selecting pairs of vertices and hitting F. Repeat until all sewing lines are in place. In Object mode, add a new cloth modifier. In the Physics tab of the Properties editor, find the Shape section and tick the sewing checkbox to enable it. Now, let's model the neck of the dress by extruding edges. First upward, then multiple times to the sides. This is also a good time to increase the density of the geometry by adding more loop cuts or applying a subdivision modifier. This whole process might require some trial and error, making changes in Edit mode, testing them by running the simulation in Object mode, and applying the modifier when good results are achieved. Remember to also sew the neck, following the same process as we did with the back side of the dress. Add sewing lines in Edit mode and run the simulation with the sewing option selected. Finally, merge vertices by distance to close the gaps and remove duplicate vertices. To do this, select the vertices used for sewing, go to Edit mode, and under Mesh and Clean Up, find Merge by Distance. Repeat this step for the neck. Still in Object mode, rotate the dress and avatar back to an upright position. Let's run the simulation again with fine-tuned collision and cloth modifier values. Select the dress and fine-tune the physical properties, stiffness, and collisions values of the cloth modifier. Set the object collisions and self-collisions distance values to a low value, such as 0.001. You can now disable the sewing option in the Shape section. Then, select the avatar and set the thickness outer value of the collision modifier to a low value, such as 0.002 or less. It's possible to run the simulation with a higher poly count without affecting the actual density of the geometry. This approach can sometimes yield better results. To do this, apply a subdivision modifier and move it to the top of the modifier stack so that the cloth simulation takes into account the higher geometry density. Once you are satisfied with the simulation results, apply the cloth modifier in Object mode. You can then switch to Sculpt mode and use different tools to fine-tune the shape of the dress to your liking. We can now delete the avatar and move on to creating the UV map, which describes how textures wrap around the 3D model of the dress. Switch a secondary window to UV Editor. Then, go to Edit mode and define seams by selecting edges and using the Mark Seam tool from the UV menu. Try to place your seams in less visible areas, such as the back of the dress and the neck. Next, select the entire dress and run Smart UV Project from the UV menu. This should work well enough with a simple pattern like the one we are using. The UV map is a critical element when projecting textures on 3D models, so it is worth spending some time editing it to make the projection more intuitive. Next, we are going to animate our avatar. To do this, we can use motion capture animations available on Mixamo, a free online service that automatically rigs and animates 3D characters. Locate the same FBX file that we previously exported from MakeHuman Creator and upload it to Mixamo. Once uploaded, define the positions of the chin, wrists, elbows, knees, and groin of the avatar. Wait for the automated rigging process to complete, then assess your results. Repeat if needed. Using the search tool, look for a walk animation. Set the overdrive to a lower value and ensure there is enough room between the body and arms by increasing the arm space value to prevent the arms from colliding with the dress during simulation. Tick the In Place checkbox so that the character does not walk away. Once you're satisfied with the animation preview, click on Download. Select FBX as the file format, with skin, 30 FPS, and click on Download. Import the FBX file into Blender and select the armature. You will notice that the dress no longer wraps around the animated version of the avatar, which could cause problems during simulation. To address this, open the timeline and select all the keyframes. Move them forward by, say, 50 frames. Now press the Auto Keying button, switch to Pose Mode, and locate Clear Transform All from the Pose menu. Finally, unselect Disable Auto Keying. To achieve a better looping cloth animation, it is recommended to make it loop at least once during the simulation by duplicating all keyframes corresponding to the walk cycle and moving them right after the first one. Now, apply a collision modifier to the rigged avatar and a cloth modifier to the dress, using the same values as last time. Also, add again a subdivision modifier and move it at the top of the stack with a value set to 1. Instead of playing the simulation in the timeline, use the Bake button in the Physics tab of the Properties editor. Once baking is complete, check the animation. Fine-tune the cloth modifier and repeat the process until you achieve good results. Adjust the rendering range in the timeline to the start and end frame corresponding to the repeated walk cycle, and check that it loops nicely. We are almost there. Since Canvastique 3D only supports GLB files, we need to encode the animation, so it is compatible with this file format. To accomplish this, we can leverage shape keys to record the position of vertices for each frame of our animation. This approach can be long and tedious since it involves converting each set of vertices generated by the cloth modifier during the baking process into a shape key, for as many frames as there are in our walk cycle. This results in a collection of vertex positions. We would then need to control their state from the timeline by using keyframes to set their value to 1 if they correspond to the current frame, or 0 if not, and do so for every frame. As I said, this is a long and tedious process, but fortunately there are a couple of options to automate it. We could export the dress as an Alembic file, upload it online to Sketchfab, wait for it to convert into multiple file formats, and then download the GLB version. This process requires a Sketchfab account. Instead, we will stay in Blender and automate the process using its Python API. Hence, we need to use a Python script. I tried using ChatGPT by describing the basic algorithm and managed to get a working script. Before moving further, I must mention that the sources used by ChatGPT in its answer led to a script shared by a user named Grady Nelson on Blender Stack Exchange under a Creative Commons license. Huge thanks to Grady, and please check the link at the top of the script for information about the exact type of license before using it in your own projects. Change the Blender layout to scripting, create a new text file, paste the script, select the dress, and run it. This will result in a collection of shape keys and a keyframed animation that controls them. You can now export the dress as a GLB file and bring it into Canvastique 3D.